My name's Matt Fife. I'm a developer on the graphics performance analyzer tools in the INDE suite. And Seth Shiner's also here today. He's our technical consulting engineer. We both will be available afterwards and giving demos afterwards and answering questions. So we'll go ahead and move to our next page. So there's a lot of tools out there today to help you as a developer. Intel has its own set of native tools that can help you optimize and get the most out of your applications. Currently, these tools are all collected into the Intel Integrated Native Developer Experience, or sometimes known as the INDE suite. So our tools are unique because we write them to be aware of our special hardware features of our platforms. So they work on a wide variety of development platforms and development environments, and also work on the whole host of range of GPU and CPU hardware that we currently make. But today we're here to just specifically talk about GPA. So for those of you who have not used GPA before, GPA stands for the Graphics Performance Analyzers. It's a suite of individual tools that you can run on your favorite development environments. We run on Mac, OS X, and Ubuntu. So these allow you to analyze applications on Windows, Ubuntu, or Android platforms as well. We help you isolate and fix any of your performance problems. So as developers, we've all had the experience that once you have your primary functionality in place, you start testing it on a number of platforms, and then you might discover performance issues. So most of us have performance goals for the different platforms that we have, but these goals are even more difficult to hit on the wide variety of hardware that we have out there today. Lag, low FPS, stuttering, these are all serious issues. And we as developers want to provide the best experience when people play our games and apps, no matter where they use them. So GPU can help you identify your hotspots and reach your performance goals no matter which of the targets that you're targeting. So how do our tools work? Because we run on such a wide variety of platforms, our tools have a host and target architecture system. The reason for this is twofold. First, everyone has their own favorite development environments, and nobody likes to have to switch. And second, because small handheld devices don't lend themselves to interactive debugging tools. Also, when developing on low power, low compute devices, the monitoring tools themselves can actually get in the way of getting accurate measurements and affect the performance themselves. So in order to get the best results, we run small collectors on the target systems, but have our powerful analysis tools that run on your development system. But even if you're just a purely desktop developer, this mechanism actually gives you the ability to remotely debug and remotely collect data on platforms that you might be developing on as well. So what platforms do we run on? As you can see, we have a wide variety of them. We currently support collecting your favorite versions of DirectX on Windows hosts. For Android gaming, you can use a Windows, Ubuntu, or Mac OS X to collect data, and you can see the various Android OSs that we support there. We also support Ubuntu. This is new, kind of a new feature for us. So this has also come online, and this is constantly updating. So if you have suggestions for platforms that you would like to see, please do let us know. Whoever yells loudest gets theirs first. So what are the tools that are inside GPA? So there's four tools, four primary tools. The first is System Analyzer, up there in the corner, which allows you to connect to your applications and not only monitor real-time metrics, but also override the state, trigger frame captures, and make traces. And we'll talk about captures and traces here shortly. Graphics Monitor is the next one. It's a lightweight monitoring tracing tool. The component allows you to launch applications, monitor them via simple HUD, again, collect frames and traces, trigger events, and then manage the various configurations for the apps that you want to capture. The third application is Platform Analyzer over in the left. So this tool allows you to visualize GPU and CPU load at the same time. It allows you to see spots that are difficult to spot if you're just using a CPU analysis or GPU analysis. You can actually see how they're interacting with each other. There's definitely a whole class of problems that just arise from interaction problems. And then finally, there's the frame analyzer tool, which is my favorite one out of the lot. And it's a really powerful frame analysis tool. You can capture individual frames of your game and inspect all aspects of them and find performance issues at the individual draw call level. So you can capture a whole frame and just dig right into it. All right, so this slide, don't let this slide daunt you too much. There's a wide variety of ways to find performance bottlenecks in your application. But one of the most methodical ways to isolate what you're looking for is what I'll show here, especially if you don't know where to start. At a high level, our first objective is to find out if we're CPU bound or GPU bound. After we discover that, we can start making the right kinds of performance optimizations. After all, you don't want to spend your time optimizing CPU code if your problem's on the GPU, or optimizing your GPU code if your problem's on the CPU. So first we do what we call real-time analysis, or online analysis over on the left. Let's say you have a performance issue in your game, and you start your analysis either on the system you're using or connect to it remotely. For Android, you use your normal development system and connect to your Android application on your actual Android device. Then you run your game under analysis using System Analyzer or the monitor, and then you can capture frames and traces. So now we'll talk about frames and traces a little bit. A frame capture collects all the graphics APIs for an individual frame. A trace capture, however, captures both the CPU and GPU activity and give you an overall picture of what the system is doing. We can capture any number of frames or traces during a run of an application or a game. If one particular level is causing you problems, you can go to that level and just capture frames and traces from there. After you have your frames and traces, we can then use the analysis tools over on the right to figure out where the problem is. We'd probably first analyze the traces with Platform Analyzer. You'd see there. This will quickly tell you if you're spending the majority of your time on the CPU or the GPU. After you find out if you find out that all your work is happening on the CPU, you can keep using Platform Analyzer or use another tool that Intel makes called vTune and really dig into what's using up all the time on your CPU. If you find out that you're GPU bound, that's when you can go to the top route and use Frame Analyzer. And that allows you to, in the same way, break down your frame and find out exactly how much time you're spending on every single draw call that you're making in your frame. So this all sounds great, but how easy is it really to use? It turns out it's amazingly easy. So when analyzing any of your applications, it requires absolutely no code changes at all. You can take your game as it's being built right now and run GPA on it. You don't need to recompile. You don't need to fill your code with instrumentation macros, nothing. For analyzing Android applications, you don't even have to root the Android device. You can just use it as is. You don't even have to connect to the Android device directly. You can do it over the network with ADB. So it's extremely flexible and extremely non-intrusive. There's really no, you should try it today. So now that we've seen the overall workflow, let's look at the individual tools. So System Analyzer, Frame Analyzer, Platform Analyzer. As we mentioned before, System Analyzer is probably the application you're going to use first. So what System Analyzer allows you to do is connect to your application and gather real-time information as your game is being run. You can view highly detailed CPU and GPU activity, power metrics, and a host of other platform data, all captured in real time. The graphs help you quickly see if you're not only if you're CPU or GPU bound, but if there are any activity spikes. If you have stuttering or lag issues with certain actions in your game, you can very quickly reproduce them and see where the spikes are coming from and figure out which side of your, or where in your compute that's happening. The real-time power analysis has actually become even more important on mobile platforms. sometimes the biggest power hogging activities are not at all what you expect. When we analyzed a lot of Android applications, we were trying to find out where the power was being used up. And what we found was that it actually happened on the menu screens and on the pause screens and the menu systems that popped up. And the reason for that is because most games run with no FPS limit on them. And because title screens and menu screens are very easy to draw, and they draw really fast, you're drawing it usually like hundreds of frames a second. And all that flipping is actually extremely power intensive on the system. And you didn't realize it because what happened was when you put the device, you just clicked it off or whatever, it was sitting on a menu screen or a title screen, and it just chewed your battery up while you were at it. So these kinds of real-time analysis are really important because it helps you actually have real data and know exactly where you're actually spending your time or using up all your power without making optimizations on the wrong things. So here's a little bit blown up view of System Analyzer. You can see on the left-hand side all the different kinds of metrics that you can gather out of the system. There's also the ability to run real-time overrides. You can see them there in the bottom, the state overrides. So when you're running your game and app, you can actually turn on and off these state overrides and quickly see what effect they have on the frame rate, on power, on CPU, GPU load. So it allows you to really quickly see if you're draw call bound, texture sampling bound, or any number of other common problems. Also, last but not least, this is kind of neat. At the top, you can see there's a pause and single step. You can actually pause your application on any frame you want and then step frame by frame while you're playing it through the game that you're running. That turns out to be really good for catching like single frame glitches. One other thing that System Analyzer has, this is really neat. So not only do you get like frame rate and the current FPS and things like that, but we also have this neat setting down on the bottom. If you run the tool on Intel platforms, you can actually change the frequency of your CPU and bound it, and then try your game on a host of, pretending that you're slowing the system down or speeding it up to see how your game runs on different environments. This way you don't have to buy your own host of different machines to try this on. All right. Here we are, some more details, continued. Here's the experiments that you can run as well. You can kind of see visually what they're doing down there. Wireframe is one. Disabling draw calls, if you have particular draw calls that you suspect are or if you suspect that your draw calls are your limiting, you can disable all the draw calls, and you can immediately, if your frame rate doesn't go up, you know immediately that you're CPU bound, not GPU bound. So each of one of these little experiments can usually help you start tracking things down, and you can do them within seconds to start tracking down what you've got. So System Analyzer is great, but what if you want to analyze full screen applications, don't want to connect to it? You can certainly monitor your application remotely, but what we also do is internally, we actually pop up a HUD inside your game, and this happens automatically once you start analyzing it. You have almost the same set of controls as in System Analyzer. You have just a fewer number of graphs that you can track, but all the same activities are there. You can run all the experiments that you wanted. You can trigger captures or traces in-game. Doesn't require any code changes on your side. You just run it, and then you get this heads-up display automatically. We should note that on Android platforms, since the form factor is so small, you usually can't read them, so we just disable the HUD on Android, but you can still trigger the same things using System Analyzer. Here's an example of the metrics that we get on real-time on System Analyzer and the HUD. Obviously not as many as you can pick in the System Analyzer, but it does give you the probably four most common or four most popular ones that we use. How much load is your CPU and GPU, how long each frame is taking for duration in microseconds, and then the number of pixels you're actually rendering. Again, you can trigger any of these in real time. So while you're playing your game, like you say over the right, you just trigger wireframe, immediately everything pops into wireframe mode. So again, all with no code changes. So as we mentioned before, we have Monitor. Monitor is an application you can use to launch and use the HUD inside your applications that you want to analyze. So one of the neatest features of this, however, is the ability to select triggers. You can actually see the tab up there called triggers. Based on any of these parameters, you can actually set triggers that capture frames, capture traces. So let's say you have a game that every now and again the frames per second drops for some reason, for like 2 or 3 frames, and you don't know why. But it only happens every now and again. It's really hard to capture that sort of a activity with just the keyboard or pressing a button, like catching it. So you can actually set triggers, and if the frame rate drops below a certain rate, or the CPU load gets too high, it'll automatically capture that frame so that you can go back later and analyze what happened to it. All right, Platform Analyzer, next tool. The Platform Analyzer tool is great for monitoring CPU and GPU activity at the same time. This tool helps you figure out it helps you figure out how efficiently you're using your CPU and GPU resources. Often there's cases in early development where we have unbalanced workloads. We either have too much work going on the GPU and the CPU sitting idle, or the CPU is doing too much work and the GPU is sitting idle. This tool really quickly helps you figure out which one of those situations you're in. As you start optimizing, you'll find that you can start correlating the data and finding out if you're causing interactions that cause either the CPU side or GPU side to pause. And hopefully I can give you a little example of that. Here's a good example. So there's a ton of information in this tool. There's not enough time to go over it. But here's a little overview and some really quick things you can catch. For example, here you see the GPU and thread usages over the timeline of your capture. So you can see the app running in the bottom, and in the top you see the CPU, you see the GPU usage going on. So in this case, we have a frame that has a GPU bubble that shows an area of poor GPU utilization. There's nothing going on in the GPU. Maybe there's something we could do about that if we notice it. On the CPU side, if we notice lots of concurrent activities and we know we're running on few core machines or no core machines, we might recognize that as an area where we might start having contention. There's a whole lot of other information. Threading is on here, and we can give you a more in-depth demo of this a little bit later if you're like, but a very powerful tool for helping you figure that out. And now, finally, the final tool in the suite, which I think it's my personal favorite, which is Frame Analyzer. Frame Analyzer runs on both DirectX and OpenGL ES frames. If you discover that you're GPU bound, like we did before, if we run through our tools and we find out our problems on the GPU, you can do a deep dive into the frame you want to capture. So you capture a frame, and now you want to figure out what went wrong in there. Why is this frame so slow? Not only that, but not only can it tell you where your bottlenecks are, but it's a great debugging and diagnostic tool. You can inspect any texture, render target, geometry, shader, buffer, graphics API call that you made in the entire frame and see if changing them or inspecting them for errors makes any difference to your application. It's tremendously powerful. So this is what Frame Analyzer for DirectX looks like. OpenGL, the OpenGL version, obviously, since OpenGL is slightly different, has a slightly different workflow, but the elements are very similar, and the functionality will be nearly identical. There's a lot in this tool, so we'll take it one little piece at a time, kind of just to give you an idea of what it looks like. So usually people start with these areas right here. At the very top, you'll see the bar chart there. So the bar chart shows what we call Ergs. So as people who program in OpenGL and DirectX know, not every single DirectX or OpenGL call you make actually results in GPU activity. And so consequently, we came up with this term called Erg, which is any GPU or any command that's issued that actually generates activity. So you select your Erg or a range of Ergs, and then you'll notice that right here, the Ergs that you selected actually show up in pink, so you can tell exactly which erg that you selected. We also have a histogram mode in which you can actually pick an item on the screen, and then you'll get a list of draw calls that hit that pixel, and then you can go backwards too. So if you want to see, if you're like, hey, how long does it take to render the staircase, I can click the staircase and go backwards and find out which ergs are up there, and then go that way. You'll also see these high precision metrics for the data collected that rendered that frame. And if you select different ranges of ergs, these numbers will change in real time and show you how much time you spent on that. So if you find issues, again, it would be great to test them right away. So just like in System Analyzer, you have experiments. You can select certain ergs and then disable them. We have this thing called Simple Pixel Shader. You can replace the pixel shader on the fly and get a simple pixel shader and see how long, see if that makes any performance difference. And again, you'll get the data right away in real time. All right, texture analysis. So probably the biggest thing we pass around in our system is textures. For any draw call, you can see what textures are bound and inspect them. You get the formats and the sizes like that. This is really good for catching problems where you're like, oh, why am I binding a 2K by 2K texture? I really wanted a 512 by 512. Another useful feature is the geometry inspector. You can pick an erg or two and then see all the geometry that was rendered for it. Again, another common problem is sometimes the geometry you're rendering is just far too highly tessellated for what the purpose of the draw call should be. This can help you figure out if you have any issues there, or if you're using a strange format that you shouldn't be using. Also handy. Let's see. The shader editor itself, yes. So this is really powerful as well. You can actually pick ergs, and you will get the actual shader code that was generated for that shader, and then edit it in here. You can actually replace the shader itself with another file if you wanted, and load another shader. Yeah, and the results immediately appear on your screen. You get a brand new render target with the new shader output, and you also get new metrics for what you used in there. It's the same process as using Simple Pixel Shader, but you can edit it in there on the fly. If the HLSL is available, you can edit it in HLSL. It also shows the assembly if the source isn't available. So again, we also provide this for OpenGL. OpenGL's, the layout is a little bit different, and there's slightly fewer features just because OpenGL ES doesn't have as many features. You can also pick one of the neat features is you can pick the color layout like you can in Visual Studio. You can go light or dark layouts if you like. Again, some of the features have moved around a little bit, but they're all there. So we have the familiar erg bar chart at the top. We have the API log on the left. The metrics also get reported for the height of the bars, tell you how long they took. Obviously, on Android devices, there's sometimes fewer metrics captured. So your metrics may vary by the device that you're capturing from. Let's see, experiments, again, available in OpenGL as well. The texture viewer, this is probably one of the most handy ones for running on Android and small OpenGL ES form factors because textures matter so much. One of the things that can commonly happen is your game runs fine on one platform, you run it on another Android platform, and it runs terribly. It might be because of your texture format isn't optimized for that particular platform. So checking your format, checking which parameters you're using when you're binding it, all can help you figure out, and you can change those, use drop-downs, just drop down and say, let's try linear filtering for a change and see if it's the filtering or if it's the actual texture itself. So also very, very powerful. Again, geometry viewer is also available in OpenGL ES. Again, shader editing is also available, so you can inspect the shader, make changes in the editor in real time, and the change shader will actually show up. You also get the shader uniforms in OpenGL ES, so you can check what's bound where and what the values are. So we were going to do a little demo, but I think we're going to cut it short today. We can take a few questions. We're out of time. OK, so we're out of time. But we will be doing a demo of this over here. Please come by and check it out. It's a powerful tool, and we'd love to see what you guys have to suggest for features and things like that. So we have a long list of features we want to add, and you guys get to pick. So thanks a lot.